Hello friends and welcome to my channel. In this video I am going to talk about Formula 1 downforce and drag. How will it affect the performance? So let's begin. Most of us are considering downforce as a better thing, but I have to say downforce is an evil. It have bad side and it have good side. So let's discuss. It is because downforce is the byproduct of aerodynamic drag. If we have higher downforce, there will be higher drag which will resist the motion of the vehicle. So a car with higher downforce definitely have more air resistance. So the car need to produce more power for propelling forward with higher acceleration and to achieve a better top speed. So by designing a hypercar or a super sports car or a racing car, we have to make a compromise between downforce and top speed as well as drag. If we prefer downforce, we have less top speed like just go. And if we chose top speed, we have less downforce like just go absolute. Do you know a Formula 1 car weighs around 740 kg and it is able to produce a downforce 3 times its weight, which is 2220 kg, which is 2.22 ton, which is 3 times the weight of the car. The car is able to produce a downforce which is equal to 740 kg, which is equal to the weight of the car at 130 km per hour. This is why Formula 1 cars is able to take corners at that much huge speed. The contributors of this downforce is the front wing, the venturi tunnel, the side ports, the dashboard and the rear wing of the Formula 1 cars. The front wing of the Formula 1 cars generate 23% of the downforce and 60% is generated by the diffuser, by the ground effect and 17% by the rear wing. Here the red color shows higher downforce and blue shows lower downforce. The turbulent air made by the leading car will reduce the downforce of the car that is following, because the following car is only able to produce a downforce of 25%, so it will have lesser handling. Mainly the car is following by 100 meters. The front wing is the main part that is affected. This figure shows the airflow and the downforce generated in the front wing and the rear wing. Here you can see the center of pressure is denoted by blue and it is varied with respect to the acceleration. As I already said, the front wing generated downforce more than 25% and the rest of the bodywork such as dashboard produces a downforce between 5 to 10% and the underboard with diffuser produces a downforce greater than 45%. Nowadays it is about 60% and the rear wing produces a downforce between more than 25%. Summing up all this, the Formula 1 car can produce a downforce 3 times its weight. Now take a closer look at downforce and drag that is generated by all the aerodynamic aids. First, the front wing assembly produces, you can see the top, it is downforce. And the left downside it shows the percentage of drag produced by. It's an old Formula 1 which is the 2009, but it is relatively the theory is same. Here you can see the most higher downforce is created in the diffuser side, and second the front wing, and third is the rear wing. Here you can see the negative lift is created in all these 3 parts, and the negative downforce is created in the chassis and body part. Here you can see that most higher contributor of drag is the rear wing. So if we need more downforce, the aerodynamic drag will definitely increase by a little or by a huge amount. Let's look more closely how the horizontal air force makes the drag as well as downforce. For that, I will show you a diagram. Consider the inclined surface as the rear wing. The angle of attack is the angle of that rear wing. Here you can see the fluid velocity, which is the velocity of air which is contributing to the horizontal force that is impinging to the surface, which is the rear wing. You know that due to the inclination there will be 2 force components. One is the vertical component and one is the horizontal component. And the vertical components contribute to the downforce of the car. And the horizontal component, simply it is the drag force that is resisting the motion of the car. Here you can see the representation. Y component is the downforce and X component is the drag force. The magnitude of downforce and drag force is directly dependent on the inclination of that wing or the aerodynamic aid equipment. If the wing is inclined by an angle of 90 degrees or it is completely vertical, we will have a dominated drag force. There will be no downforce, it will be completely drag force. And this position is used for providing air brake in supercars. Here are the completely vertical portion. And the zero angle position is used for drag reduction system for or DRS mode, where we'll get completely higher top speed by reducing the drag completely in Formula 1. And this effect of downforce made the Formula 1 car able to travel upside down in a tunnel with a speed greater than 130 km per hour. Now you must be able to tell the relation between downforce and drag. Thank you for watching my video and don't forget to subscribe to my channel and bye. Have a nice day.